of coordinate geometry. We are going to discuss today different types of centers like circumcenter, incenter, centroid, orthocentre and excentre. Okay. Perhaps these questions are asked in constructions also when you are going to discuss about locus, right? So first of all, let's discuss about circumcenter. The definition says that it is a point of intersection of all the three right bisectors of a triangle. Right bisectors means perpendicular bisectors. Okay. So circumcenter is the point of intersection. Intersection means meeting point. Okay. Point of intersection of all the three perpendicular bisectors of the sides of the triangle. Okay, of the sides of a triangle. Okay, now let us take a triangle. Suppose this is the triangle ABC. Okay, if you get the right bisector of BC, right bisector, how you do? Put the compass needle here, pencil point here, and draw one arc like this. Okay, with the same measurement, cut one arc below like this. Now try from here, from C, putting the compass needle here, pencil point here, you try to intersect these two. Now join these 2 points by taking the impression of compass. So this is the perpendicular bisector of BC. Perpendicular also and bisector also, right? Now try another bisector. Suppose you have bisected AC in the same way. Draw the right bisector of AC like this. Okay. Similarly, if you draw the right bisector of AB, okay, even this passes through the same point. Okay. So this point is called the circumcenter. Okay. Suppose this is the point P, let us take. Okay. Then P is equidistant from A, B and C, right? So P is the circumcenter, okay, and P is equidistant. That means the distance of the P is same from A and B and C. So P is equidistant from A, B and C, okay, and you know what is this called? PA equal to PB equal to PC, and this is called the circumradius. Okay, that means if you take P as the center and radius equal to PA, and if you allow this to pass through all the three vertices, it will describe a circle like this, and this is called the circumcircle. Okay, so this is called the circumcircle. Okay, this is the circumcenter. Okay, and this is the circumradius. So what is circumcenter? It is the meeting point of the three perpendicular bisectors of the sides of a triangle. That is the definition, right? And it is always equidistant from the three vertices. What are vertices? The meeting point of the lines. This is the vertex A, this is the vertex B, this is the vertex C. Okay? So this is all about circumcenter. Now let's come to incenter. Incenter is the point of intersection of the three angular bisectors of a triangle. Incenter is the point of intersection of the three angular bisectors of a triangle. Okay, since a triangle has three angles, so we are going to bisect the three angles. Let's take the triangle ABC again with any measurement. Okay, now if the angles are not drawn, please take a suitable arc of say 2 cm and draw an arc like this. Now put the compass needle here, draw an arc. With the same measurement, draw another arc. This is the intersection point. So this is the angular bisector of B. Okay. Now do the same. Take a suitable radius, same as this. Draw an arc over here, bisect the angle C, and draw the angular bisector. Okay. The place where the two meet, this is called the incenter. Okay. This is called incenter. Suppose I. Okay. Now, if you take the angular bisector of A also, definitely that will pass through the same point I. So the point of meeting of the three angular bisectors is the incenter. That's the definition. Now this incenter is equidistant from the three sides of the triangle. If I drop a perpendicular on the three sides, okay, then this is equal to this equal to this. Let us take ID, IE, IF are the perpendiculars on the three sides of the triangle drawn from the point I. Okay, then we can say that ID equals to IE equals to IF. Okay, and this is called the inscribed radius. INSCRIBED, inscribed radius. In the previous figure, this was circumradius. This is the inscribed radius, and it is so called because if you take the center I, radius equal to ID, it will describe a circle touching the three sides of the triangle like this. Okay, you know what is this called? This is called incircle. Okay. So this was the circumcircle, this was the incircle. This circle was passing through the vertices, this circle is touching the sides. I mean to say AB, BC, AC are the tangents for this circle. Okay, I repeat, AB, BC and AC, okay, are the tangents for the inscribed circle or simply incircle, right? So inscribed circle is also called incircle. Okay. Now let us take the third case, the third type of center, that is centroid. In physics you might have done about center of gravity, so that is called the centroid. Okay. So let's discuss the third point, centroid. This is the meeting point of the three medians, meeting point of the three medians of a triangle. Okay, now consider this as the triangle. Now, what is a median? A median is a straight line passing from the vertex bisecting the opposite of two equal parts. That means the median from one vertex is going to pass through the midpoint of the opposite side. So let's find the midpoint of this. Okay, this is the midpoint M. Okay, join AM. Okay, we have drawn the right bisector to get midpoint M. If you join AM, this is the median. Similarly, you find the right bisector of AC. Get the midpoint N and join BN. This is the median through B. Similarly, get the perpendicular bisector of AB, get the midpoint over here. Suppose this is P. Join CP, this is the median passing through C. Okay, so this particular point where the three medians are passing is called the centroid. Okay, so this is the centroid. We represent, suppose this is by G. Okay, you know this centroid divides the median in the ratio 2:1. This is the 2, this is the 1 part. Again, this is the 2, this is the 1 part. This is 2, this is 1 part. So 2 is towards the vertex, 1 is towards the base. Okay, so this is the centroid of the triangle. Now next, discuss about the orthocentre. Orthocentre, it is the meeting point of the three altitudes of a triangle. Okay, now what is an altitude? An altitude is the perpendicular dropped from the vertex on the base. Okay, suppose you want to drop perpendicular from here on this. Okay, look at this. Suppose this is the point A, this is the point BC. Okay, if you want to drop a perpendicular from A, put the compass needle here, pencil point, you measure it and just slightly come below. Now cut two arcs, one over here, one over here. With the same measurement, move down from B, the line on B where you have cut, draw one arc here and one from C, putting the compass needle here. Now this intersection point, join with this is the perpendicular. It is not the bisector, it is simply the perpendicular from a point on the given line. Now try from here, draw perpendicular from here. This is one altitude. Okay. Similarly, draw a perpendicular from here on this. This is the altitude from B. Suppose this is E, B, altitude from B on AC. This is AD, altitude from A on BC. This point is called the orthocentre. Definitely, if you draw perpendicular from here on this, okay, then this will also pass through the same point, and this point is called the orthocentre. Okay, so orthocentre is, suppose we are represented by O. This is the orthocentre, the meeting point of the three altitudes of a triangle. Okay, the last center is left, and that is the excenter. Excenter, it is the meeting point of any two exterior bisectors of a triangle. Okay, now what are exterior bisectors? Suppose this is the triangle ABC. If you produce AB, this is the exterior angle. Okay, if you produce AC, this is the exterior angle. Okay, now try to bisect this angle. Again, putting the compass needle here, draw one arc with the same measurement from here, compass needle, you cut this arc. This is the bisector of angle B. Do the same here. This is the bisector of C. Okay, the meeting point gives you E, which is the excenter. Okay, now if you drop a perpendicular from E on this line, same as we did here. Okay, this perpendicular gives you the measurement of the radius of the X circle. Suppose EM is the perpendicular from E on BC. Okay, if you put the compass needle here and measure this radius and draw an arc, it will measure the radius of the X circle. This is the X circle, touching the two sides of the triangle produced and the third side. Okay, so this is called the X circle. This is the excenter, the meeting point of any two exterior bisectors of a triangle. Okay, so these are the centers which are very important. I hope you will put a lot of stress. Okay, there are questions on coordinate geometry also based on these centers. Okay, so first try to locate and discuss about by constructing this. Okay, thanks for watching.